Thank you very much. So I'm going to present joint work with Laurent Tout-le-Monde here. It's a new method for measuring the educational gradient of period fertility behavior in Europe. It's true that this method paper has recently been published, but we are going to compute now measures for all European countries and 2 decades, and so we will just start with the substantial analysis here, and so any feedback also on the method is still highly appreciated. So the starting point is that we observe as demographers that total fertility rates stagnate in a lot of European countries currently. They even decline in a couple of countries. But we do not really know who is particularly concerned within European countries by this fertility decline, and why are groups, for example, lower educated or higher educated, more concerned than other groups by the fertility decline. What we know so far from the empirical literature is reasons for between country differentials in terms of total fertility rates, so the overall levels in countries. So we know, for example, that, well, institutional support for dual earner couples and more modern gender and family norms normally are positively correlated with total fertility rates in European countries. And what we also know in terms of within country fertility differentials is that if we focus on completed cohort fertility, there is more or less in all European countries so far a negative educational gradient. But it's not really so sure that this is also the case for period fertility levels. We have just heard a couple of studies suggesting that it's more and more the lower educated that might face more constraints in terms of fertility behavior. So currently we miss data and measures on the educational gradient of period fertility levels covering all European countries. Most of the empirical literature focuses, due to technical methodological constraints, focuses on fertility rated to only one birth order, so fertility transition probabilities of first birth, second birth, and so on. But so far there's no study that combines information of parity-specific birth hazards to see in how far these hazards transform into levels of period fertility. And one of the reasons why this demographic calculus in terms of period measures does not exist so far is that the calculation of age-specific fertility rates by education is quite complicated, if not impossible, because education evolves over age, okay? And if we calculate a total fertility rate with a purely cross-sectional setting, we would completely underestimate total fertility rates for the low educated, because at ages 15, 16, 17, more or less everyone is low educated in our sample, because women have not yet completed their education. So what we propose is this new method based on EU-SILC data, which has a couple of inconveniences for demographic research that you might know, but the big advantage is nevertheless that it covers more or less all European countries and more than 2 decades. What we propose is a semi-retrospective approach to observe fertility behavior of those cohorts that are currently at childbearing age, so 15 to 49 in each calendar year, but while at the same time recording the educational level correctly. We also apply Bayesian statistics to obtain credible intervals for our birth probabilities, which are not only age and education, but also parity specific for each European country. So we run into sample size problems for certain probabilities. We use multi-state life tables to obtain parity specific and total birth intensities by education. And last but not least, we apply a post-stratification procedure to be consistent with national estimates of period fertility. So here, for the purpose of demonstration, I will show you period fertility levels by education that we calculated for 2010. We started with 2010 because we want to compare our measures here with census data also, to make sure that there are no education-specific biases in our measures. And so for these fertility levels service for 2010, we use the cross-sectional sample of EOSILC of 2012, and we use a 2-year delay between the year of observed childbirth and the survey year, which is necessary to significantly reduce fertility-linked attrition, which is present in SILC, and we distinguish between 3 classic education levels, low, middle, and high. So this is just an illustration for our semi-retrospective approach. So we use for ages 25 plus a synthetic cohort approach. So we use the cross-sectional wave 2012, with which we observed fertility behavior in the calendar year 2010 for women aged 25 plus in 2010. That means at the same time in 2012 for these women we observed their educational level when they are at minimum age 27, and here at age 27 we consider that for the majority of women in all countries education is completed. So we identify education correctly in a cross-sectional setting from 25 on. And below 25 we apply a retrospective approach, meaning that we choose one cohort, women aged 27 in 2012, and then we retrospectively in a longitudinal perspective observe their age-specific fertility behavior from ages 15 to 24. And so this allows us to have a relatively current information of fertility behavior for each calendar year, all by observing the educational level correctly. And we also combine 3 waves to increase sample size. As I already said, Bayesian statistics help us to obtain credible confidence intervals. So we compute the posterior from the prior with Bayes' theorem. Specifically, that means that each age and parity and education-specific probability is estimated based on a prior. The prior is here the age and parity specific probability, but averaged over all education groups, and then the posterior would be the age and parity and education specific probability based on the prior. And let me show you some results now directly. So these are birth intensities by education in France for 2010. You have here different intensities by age, by education, and by birth parity. And what we see in France is it's quite striking that there's not so much differences in birth intensities at age 49 between education groups, and in particular not for first childbirth. So the higher educated women, the higher educated women here, they do not have significantly lower birth intensities in comparison to the lower educated women. And that is also true for second childbirth. And then for third childbirth in France, we start to observe a quite classic negative educational gradient. But this negative educational gradient only starts from third childbirth and then increases. And then as a consequence, we see that the all birth orders combined, the total birth intensity is not so much lower for the higher educated in comparison to the lower educated in France. So also for the high educated here, the black curve, you have a total period fertility level of 1.85 children per woman, which is quite high for high educated in the European comparison. Now the contrast to France is Germany, neighboring country, but very different fertility behavior. And here you see that there is really a very classic educational gradient starting already from first childbirth. So we all know that childlessness is quite high amongst the higher educated women. And also the illustration here shows quite well that it's not only for highly educated women, but also for the middle educated. The middle and the high educated have lower birth intensities, not only for first, but also for second and third childbirth. And then all birth orders combined, we see that the birth intensities are indeed lower here for the middle and the high educated, much lower for the middle and the high educated in Germany. So we can calculate these total birth intensities for all European countries. We have selected here 6 countries just to illustrate you a little bit the potential of our measurements. These 6 countries are more or less representative for different European regions, and what you can see here quite clearly is that there is actually not so much heterogeneity in total birth intensities in Europe for low-educated women, but there's a lot of difference between country difference when it comes to total birth intensities of middle and high-educated women. And so in order to focus a little bit on the differences in the educational gradient between European countries, we decided to normalize total birth intensities here for the low-educated, and so here you can really see the difference in the gradient between the 6 selected countries, and typically here in the lower fertility countries, Italy, Germany and Poland, the educational gradient is still very negative, but much less negative in Sweden, France and the UK. And again, the beauty of working with EUSEC is that we can really cover all European countries. So here we have 28 European countries covered in 2010. I will not comment on each particular country, because here again my purpose is just to show you what we can potentially do with the data. So all European countries are covered more or less, and we also can calculate yearly measures. So for the moment we have measures for 2005, 2010 and 2015, and we're just about to calculate yearly measures from 2003 on. And what you can see here is if you compare 2010 and 2015 in particular. So for France, for example, you see France has experienced a quite significant fertility decline over the between 2010 and 2015, and our measures here suggest that it's particularly the low educated that are concerned by this fertility decline. In Sweden, in contrast, also a country that experienced a quite dramatic fertility decline, here it seems that it's the lower, the higher educated, the high educated that are particularly concerned by the decline. And when we observe our intensities by age, we really see that there's a big delay of childbirth going on, in particular for the highest educated. And Germany, for example, which experienced a slight increase in period fertility levels, we can see here with the educational gradients that it seems that it's more the high educated that have benefited from that increase, so that have experienced this increase in period fertility. So what are our next steps? We will calculate these measures for all countries, and yearly measures from 2005 on. We will intensify our data quality check by comparing our measures with alternative databases, country by country, and last but not least, our substantial analysis. What are the determinants of the educational gradients, the differences between countries in the educational gradients in Europe, and the evolution of the educational gradients within each country. So we can answer with this then hopefully soon why, for example, the high educated in Sweden face this particular fertility decline. Thank you very much.